winds upwards of 100 to 105 miles per hour.
Yeah. Have you ever been through a waterspout like that?
No.
Yeah.
I've never seen anything like that before.
No, same
Amazing.
here. That is amazing. Well, here's a layout of what actually happened. This is the coastline here in the Fort Walton area, the Gulf of Mexico. We've got the Santa Rosa Sound that separates these two. So that storm was over the Gulf of Mexico and it moved on shore here. This is where Dave shot that video. So he was pretty close, but you can see it crossed over the sound and then back onto land.
We're pretty lucky that it didn't come right for the condo building he was at. Listen, we've got really strong structures. They're built to hurricane code down here, so I'm sure the building could have taken it, but they needed to be inside in some shelter. When we look at the radar, not a classic hook echo necessarily, but you could tell where the storm was.
Absolutely. Looking at this is not your typical waterspout. This was associated with a supercell here, a storm that moved on shore, and it doesn't look like that classic hook, but look at this appendage. This is definitely a hook-like echo, and it's right in here where we've got this inflow. That's where we experienced that tornado as it moved on shore. You
take a look at the velocities. What this shows you is which way the wind is going in the event. Where you've got the green and the red, basically right next to each other, it shows you opposing winds, which is kind of implying that you've got rotation, okay?
Yes.
Because one wind is coming toward the actual radar site, one's going away. So right next to each other, there's something like this that's happening.
Right. And it's amazing. You saw in that video how it looked like it was going to dissipate, but then right when it came on shore, it actually tightened up. You know, we actually saw that condensation funnel or the water. It actually started to form, and you can see it here in the velocity.
It got bigger when it got over the water.
Yes, right. So don't let your guard down with these type of things, because even if it's not there, it may reform again quickly.
You saw all the debris that was flying in the air as well. That's one of the dangers. You know, watch for stuff like that, because you could be hit by a piece of debris and be hundreds of yards away from the tornado.
Absolutely. I cannot stress this enough. Like, you have to be inside in an interior room, because 100-mile-per-hour winds, not your everyday garden variety waterspout for sure. Well, let's show you what's still on tap tonight on Weather Underground. We've got Report Card, Mayday, and mountains of issue for us across portions of the southeast, especially up into the mountains. Dr. Navarro joining us again, talk a little bit more about upslope terrain and what that means for the rain that falls through the Appalachians. Yeah, so upslope flow is exactly what it sounds like. It's air that's lifted up and over a barrier. In this case, the Appalachian Mountains. This is a general picture, but sometimes when you get that south flow, maybe a southeasterly flow here off the Atlantic, it brings very moist air here directly into the mountains. So if it comes in perpendicular like that, the air can't flow through the mountain. It's rock, right? So it's got to be lifted up and over. And unfortunately, when that air gets lifted up, it saturates and condenses and falls back out. So we get heavy rain here on the south-facing slopes or windward slopes on the mountains.
You know, just think about it. You know, you go up in elevation, generally the temperature's going to cool, right? Well, if you can cool the air temperature down to the dew point, you're going to saturate the atmosphere and you're going to get clouds that form. That's in essence what the mountain's doing here. It's just speeding up that process.
Absolutely. It's forcing it into that direction. So this is the windward side of the mountain. All that word means is it's the side of the mountain that's facing the incoming wind. As that air flows in and encounters that surface, it can't punch through, so it has to go up. And as Mike just said, the air up here, as that air rises, it cools up in the atmosphere. We get those clouds to form here on that windward side of the mountain. Notice it's not right on top of it. It's shifted over a little bit. And right here, when that air gets pushed up eventually, it all falls out as rain. And that's why we get this lush vegetation here on the windward side.
Then on the leeward side, that air will then spill down the leeward side of the mountain, a lot drier now because it's already precipitated out. And this would be known as the rain shadow, where you're left without. And if you look at the mountain here, this is drawn specifically. Notice, very arid here, very little vegetation, where it's so lush on this side where it rains and you've got dense forest. That's literally what happens.
That's also literally what happens in the state of Washington, by the way. Right? The two very different parts,
you had a lot of
Western and
experience
Eastern.
with that in the Cascades, right?
Yes, it's amazing. The two different sides of the states are really
different. You look at the eastern half of Washington, it is boned up. Spokane's a pretty arid climate.
Right.
All right, so let's talk about what could happen in the southern Appalachians. We've got a tour set up for you here. That's the southeast, okay? So let's zoom down in, all right, and show you what we're looking at. You take a look at a place like, say, Statesboro, Georgia. You know, this is all relatively flat here. This is only about 250 feet in elevation.
Yes.
But you don't have to go far to find some mountains, right?
Yeah, so you go up just a little bit to the north. Here's Greenville, South Carolina. Notice those mountains on the distance. Doesn't take a whole lot of elevation to really cause this effect to come into play. So it's here. The farther in towards the mountains you go, notice how here, now we're in the Ridgecrest and the Black Mountain area, much taller mountains, Mike. So these places particularly vulnerable for that upslope flow.
For sure. And then you get to the highest peak in the Appalachian Mountains, if you didn't know, is actually in North Carolina. It's Mount Mitchell, elevation about 6,700 feet. But look at the terrain here. That plays another significant role when it comes to flooding, right?
Yeah.
What you end up getting is a lot of quick runoff.
Yeah.
You know, you just don't have flat terrain. So everything that comes down the mountains goes into the foothills, goes to any little neighborhood that's down there and can potentially wash it out.
Absolutely. Very dangerous.
Oh, for sure. Please watch it. Hey, when we come back, thunderstorm threat.
And that's really shut down the severe on the southern side. But the cold air is to thank for a lot of that. And I mean, we're okay with the severe not starting very early, but very cold air has crept all the way down here. You can see the state of Kansas and Oklahoma really being underneath those temperature departures. So we've had a lot of cloud cover. We haven't had a lot of instability. We don't get the surface warming. The factors really just haven't been at play to produce this.
So let's take you through that date, the 26th, which would be when we would tie the record. It stays cool. The air stays stable here. We may not see a turn in the pattern that may spawn severe weather literally until the first day of May.
Right. So talk about crazy, right? That record could literally be right in. But I mean, we're looking ahead, so things can still change in that time frame. So don't lock in too much for that. But it does look like next week we could see a flip in the pattern where we could see severe weather come back into play for an area that we would typically expect. North Texas up towards Oklahoma and Kansas. We've got that strong wind shear coming in, and we'll see the instability start to pick up here. So maybe early next week to mid next week, that could be our next best chance for severe weather.
But even, you know, you look at Texas, we've had 11 tornadoes, I believe, in Texas. It's a big state.
Yeah.
Only 11 tornadoes, that's not much. Shut out in Oklahoma, shut out in Kansas, nothing in Nebraska or the Dakotas. I mean, it's almost unheard of.
Right, and then we've had 5 tornadoes in California, you know, which is not typically a place we would expect to see. And that's kind of creeping up on the list because it's been so quiet on this side of the country. So it's been a little wonky, if you will, you know.
To say the least.
It's like the places were like, what, why? You know, and Virginia's even had a tornado too. Maybe
it just means, though, that, listen, we've gotten a nice pass, so to speak, for the month of April, but always be ready. Always keep in mind what your plan's going to be, where you're going to go in the case of severe weather, because we know that it could literally be a flip of the switch and things could get very violent in May before we know it. And May brings Oklahoma its worst tornadoes. Its strongest tornadoes typically happen in the month of May. So.
Yeah, so keep it in mind. We're not done yet.
Yeah, for sure. Not by a long shot. Hey, still to come on the show